Hello everyone, I am AMIT, Assistant Professor in Department of Mechanical Engineering of Arya College of Engineering and IT, Kukas, Jaipur. Today we learn about the different equipments used for emission measurements in the vehicles. So let us start. Emission measurements. The emissions regulation specify the type, principle of operation used and generic construction of the exhaust gas analyzer, which can be employed for emission certification of vehicles and engines. Here are the measurement principle of exhaust gas analyzers. CO. For CO gas component, the measurement principle is NDIR, non-dispersive infrared rays. For HC gas component, we use FID, flame ionization detector, and for NOx we use CLD, chemiluminescence detector. NDIR analyzer, this is used for the measurement of CO and CO2. It basically based on the Beer-Lambert's law, which is used for operation of NDIR analyzer by measuring the degree of absorption of infrared rays radiations when they pass through a column of gas. The fraction of incident radiations absorbed is given by this formula. This is the schematic of an NDIR analyzer for measurement of CO and CO2 concentration, in which as the absorption of infrared rays radiations is measured only in a narrow range of wavelength, which has specifically a high absorbance for the particular gas. The technique is called non-dispersive infrared. In this analyzer, it measures differentials in absorption of energy from two columns of gas. As in first column, the gas to be analyzed in the sample cell, and in second, a gas of fixed composition like N2 contained in the reference cell, which is free of the gas of interest and relatively non-absorbing in the infrared region. The infrared beams from a single source is usually split into two beams at the same time and same intensity. The detector is divided into two compartments separated by a flexible diaphragm. One section receives transmitted infrared rays energy from the sample cell and other from the reference cell. The detector is filled with the gas of interest so that the energy transmitted to the detector is fully absorbed. The flexible diaphragm of the detector senses the differential pressure between the two sections of the detector caused by the difference in the amount of transmitted infrared energy absorbed. The deflection in the diaphragm is used to generate an electric signal that determines the concentration of the gaseous species of interest. A rotating interpreter in the path of infrared beam is put to generate AC signal output that can be amplified. So by this we can find out the actual amount of CO and CO2 in a exhaust gas. Next one is FID, flame ionization detector. The flame ionization detector essentially consists of a hydrogen air burner and a ion collector assembly. Sample gas is introduced with hydrogen in the burner assembly, and the mixture is burned in a diffusion flame. An electric potential is applied between the collector plate that makes the ionization current to flow and generate signal proportional to Hc concentration in the sample gas. This current is amplified and the output signal is measured. A well-designed burner will generate ionization current that is linearly proportional to hydrocarbon content over a dynamic range of almost 1 to 10 to power 6. The commercial FID analyzer have the most sensitivity range set about to 0 to 50 ppm and the maximum range reaching 0 to 1 lakh ppm. Hydrogen is mixed with the helium in the ratio of 40 to ratio 60 to decrease the flame temperature that increase flame stability. The FID analyzer is calibrated with propane or methane mixtures in nitrogen for the measurement of hydrocarbon in diesel exhaust. Sampling line and FID are heated to a temperature of 1912 or 11 degrees centigrade to minimize condensation of heavy hydrocarbons present in diesel exhaust in the sampling system. So this is the way how the FID is worked to measure of the HC emissions. Next one is CA. CA is also known as Cheminus Analyzer. When NO and ozone react, a small fraction as per the reaction presentation. Concentration of NO in the sample. In this diagram, the sample containing NO follows to a reactor where it reacts with ozone produced from oxygen in the ozonator. In the reactor, NO is converted to NO2. A photomultiplier tube detects the light emitted by the excited NO2. The signal is then amplified and fed to recorder or indicating equipment. For the measurement of nitrogen oxides, NO2 in the sample is first converted to NO by heating in a NO2 to NO converter prior to its introductions into the reactor. When the sample is introduced in the reactor by passing the NO2 to NO converter, concentration of NO alone is determined. The difference between the two measurements provides the concentration of nitrogen dioxide in the sample. The response of the instrument is linear with NO concentration. The technique is very sensitive and can detect the wide range of ppm of NOx. The output signal is proportional to the product of sample flow rate and NO concentration. As the method is flow sensitive and accurate flow control is necessary, the calibration and operations are done at the same flow rate and reactor temperature. So this is the way in which the chemiluminescence sense analyzer worked. Next is smoke meter. In the filtration type smoke meter, like Bosch smoke meter, a fixed volume of the exhaust gas is drawn through a white filter paper or specified quality. The density of the smoke stain obtained on the filter paper is evaluated using the reference meter, which gives the measure of smoke density of diesel exhaust gas. Now, mostly like absorption smoke meter based on BL Lambert's law are used. The light extensions type smoke meter are more commonly called as opacimeters, as these provide a more realistic measurement of the visible smoke emissions from diesel engines. The construction requirements, installation, and operational details of the opacimeters is also described in the figure. An incandescent lamp with a color temperature in the range of 2800 Kelvin to 3250 Kelvin, or a green light emitting diode with a spectral peak between 550 nm to 570 nm is used as light source. The light is received on a photocell or a photodiode. When the light source is an lamp, the receiver should have maximum response in the range 550 mm to 570 nm wavelength, as is for the human eye. When the light from the source is transmitted through a certain path, length of the exhaust gas spoke opacity is the fraction of the light that is absorbed in the exhaust gas column and does not react to the light detector of smoke meter. The absolute smoke density is given by the absorption coefficients in the full flow type smoke meter. The light source and the detector are displaced directly across the exhaust gas stream, usually at the end of exhaust pipe. In this case, the path length of smoke measurements varies with the cross-sectional size and the exhaust gas stream or tailpipe. Hence, conversion chart of the measured value to the absolute smoke density for different exhaust pipe diameter or path lengths are made available for the full flow smoke meters. So these are the main equipment measurement of the different pollutants engine. Thank you.